I think you can just clap it now.
Okay. Can you see it?
Yeah. There we go. Hello guys, today we're at the JHC metal shop and this video will serve as a tutorial on how to use a vertical mill. And in doing so, I will try to mill this aluminum die from this stock piece. Yeah, let's see. Okay, so to start, first we're gonna have to choose a tool, and for this operation I'm gonna use this shell mill arbor. So this is an indexed face cutter, meaning that it has inserts which will cut the material, and we're gonna face this to the specified dimension using this. Alright, so first we have to put the mill in. To do that, there's the holder here, so we just do that in, and there's a draw rod, so you can just tighten this by hand for now, and then when it gets to the top we can use an actual wrench. Alright, that's pretty tight. Now you can use these two, so this goes here and that goes there, and just tighten that up. Right, that's pretty tight. And now we will actually put the material in the vise, but if I just put it like this, you can see that it doesn't reach the cutter because it's too short. So what I'm gonna do is I'm gonna put these precision ground parallels. So these are exactly 23 millimeters. These come in a set. There's different heights, and all of the dimensions are marked on the parallels themselves. So these are just to raise your stock piece up. So I will do that. And if I now try to vise it up, you can see that it sits at a very nice height, and this should be millable. But first, I will measure this piece. Oh my god, damn. And our end dimensions are 23 millimeters, and the side I'm gonna mill now is about 27. So let's see. Okay, so now the parallels are in the vise, and now we're actually gonna put the stock in there. And because the stock hasn't been machined yet, no sides are truly flat or truly parallel or truly perpendicular. So when we put it in there, it's not gonna seat perfectly. But we can compensate for that a bit by putting a rod in there. So this is just a regular, I think, TIG rod. It's circular. So what this does is, it's gonna contact the stock piece from one side. So because it's a circular piece, it's only gonna contact with its tangent. So that's a imaginary single straight line. And from the other fixed side of the jaw, that side, the entirety will contact the piece. So if I put it in there like this, on the moving jaw side, so this is the side of the jaw that moves, I'm gonna put the rod in, and then I'm gonna tighten it. Go up. Press it down a bit. That is pretty tight. But now, as you can see, the parallels underneath are moving, even though I tried to press it down when I did the tightening of the jaw. But what happened is, because the jaws are clenching the piece this way, the force is applied this way, so it creates something called jaw lift. So as I'm tightening it, even though I'm pressing it down, the jaws are kind of lifting the piece up a bit from the bottom. That's not good. So what I'm gonna do is I'm gonna use a machinist hammer, which has sides that are softer than aluminum, and I'm gonna give it a few taps, and let's see if we can get rid of the jaw lift. There we go. Now I got the back parallel to be perfectly snug. I can't move it with my hand, that means there is contact with it. But the front parallel is still moving, but that is okay. That is due to the thing, again, not being perfectly machined, or it's just right out of the bandsaw. So this is to be expected. But we were able to get one side stuck. So that's good. And now we're actually gonna do the cutting. Okay, now that our stock piece is in place, I will turn on the DRO. So this is a digital readout of the coordinates, X and Y. So X and Y we can see there, and the Z coordinate is on the machine itself, it's here, and we can turn that on too. Alright, so now I will place the stock piece directly under the cutter, and I'm doing this so I can zero out the Z axis. I will show you how to do that in a second. Okay, now that I put the machine in this position, you can see there's quite a bit of distance between the cutter and the stock. There's two ways to bring this down. Behind the machine, might not be visible on camera, but here there's a hand crank that lowers the machine height, so that's called the machine height adjustment. But there's also a quill feed. So a quill feed is basically the height of the tool itself. So only this part is going to lower. So a rule of thumb is that you want the quill feed to be as high as possible for maximum stability. So I will try to get fairly close with the machine height, then I will lock it down, then I will come down in increments using the quill height. So when I do each pass. And this lever is the regular quill adjustment, but this is the fine feed for the quill. But to use the fine feed dial, I have to lock it down on the regular quill feed. But yeah, I will lower the machine first. I think that is maybe there is a good height, and then there's levers here to lock the actual machine height. So I will lock that down. Okay, so now we will move on to the quill height, and I have a regular piece of paper here with me. I measured this with the micrometer. This is 0.1 millimeters thick. So what I'm gonna do is I will bring the quill using the regular feed down a bit, right about there. It's like very close. Then I'm gonna lock the regular feed. And again, when I'm adjusting the machine height, the readout on the Z-axis doesn't change because it only measures the quill height. So when I lower this or this, it's gonna change the reading. So what I'm gonna do is I will put the piece of paper underneath the cutter, and I'm gonna lower the quill using the fine feed. And I'm gonna kind of try to move the paper around, and I'm gonna keep on coming down slowly and then keep on moving the paper, and at some point the cutter will catch the paper. Okay, now you can see at 11.18 I can't move the paper at all. Let's see if I should be a bit higher or lower. Let's see. That's still moving. 11. Okay, 11.15 is catching an edge. 11.17 is completely stopping it. So I will move the piece away from the cutter. And since I caught the paper at 11.15, I know that the stock is at 11.25 because the paper is 0.1 millimeters thick. So I'm gonna add 0.1 millimeter to the reading I have here. Well, if it's a negative number here, then it will be the other way around, but it's a positive number here now. It was 11.15 millimeters, so I'm gonna set it to 11.25 millimeters. Alright, once I get it to 11.25, I will press the 0 function on the quill feed. So now this 0 is the 0 for the material. So technically, if I take a pass now, it should not cut anything. But again, materials are imperfect. Not all, as this is the non-machine side, it might not be perfectly parallel. There might be some sides that are a bit higher than the other, so that might cut. But again, we got our 0 down, and we're gonna start taking cuts as in passes from now. And yeah, let's get this side machined. Okay, so now we will get to doing the actual cutting, but before we cut, we need to figure out what RPM we should use for the tool, and this depends on the material we're using, and also the tool we're using, and also the depth of cut. So what you can do is you can use a tool like FS Wizard. So this website here, you can input all of your tool parameters and your material, and it shows you what RPM you can use, and it's reading about 2500, 2600 here. But I think I'll go with 2000 RPM for this pass, and the maximum depth of cut is shown as 12.7 millimeters on the website, but again, my stock is only 27 millimeters and the final dimension is 23, so I will maybe take out 1 or 1.5 millimeters from this side because we need to come down from the other side too. So I will get this nice and machined, and yeah, let's see. Alright, so we're gonna start the actual cut now. But before that, a few safety things. Don't forget your ear protection, eye protection, and also, if you're wearing long sleeves, roll up your sleeves because you're not supposed to have long sleeves while you're operating machinery. And also no gloves so that it doesn't get caught. No loose jewelry, so I'm not wearing my watch right now. And yeah, we will use some aluminum cutting fluid. And I'm gonna spray a bit in there. And now I will put the guard on because without this guard, it has a limit switch in there. So if it's not in this position, the machine will not turn on. And this is the main on switch for the machine, so it's under here. And then there's a green button here and a red button here. So green is to start the rotation, while red is to stop it. And this is the RPM control. So I'm gonna first set, let's say, a 1 millimeter pass, and then I will lock the quill. So that's right about a millimeter. I'm gonna lock the quill, so that's a lever there, and I will turn on the machine and set the RPM to 2000. So let's hear. Alright, that's our first pass done, and yeah, the surface looks nice. And I will do maybe a 0.5 millimeter more pass on this, and then I will turn it over. Okay, so I have done machining that one side, and this is what it looks straight out of the machine. You can see the other sides still have to be done, but if you look here, you can see what's called a burr. So that's the metal extruding from the side here. We have to get rid of that because if we vise up for the next cut with the burr still in there, what's gonna happen is the vise will, include that burr onto the actual process. So it's not gonna give you the best accuracy result. So what we need to do is take a file and file the burr down. So I will do that, then I will take the next cut. Alright, so now I got that deburred. So yes, you can see there's no stick out, so I'm ready to vise this up again. And for the next pass, I will take a millimeter off the top again, but this is the machine side now, and now I'm not gonna flip this over. We did this side, right? I'm not gonna completely flip this over and do the other side now, because this is our machined reference plane now. So I will vise that good machine side against the fixed jaw so we can get a better accuracy. And again, we have to make sure that we clean the mill after we get the part of the vise, because any chips in there can cause inaccuracies. So I will clean those up real quick. Alright, so I voiced up the part again, and I will tap it in with the machinist hammer. I am using the circular rod again, for the same reason we did before, and yeah. Okay, so I got the front parallels tight, but I can see there's a very visible gap between the back parallel and the part, but again, that's due to the sides not being machined. Only our reference plane that is against the fixed jaw has been machined, so we will do the rest of the things now. But because I revised the part, I have to zero the tool again, so I will do that, then I will start the cut. Alright, now I have the part vised up, all zeroed out, and I'm gonna take a 0.5 millimeter of a cut. So I'm just trying to machine the sides, and I'm not trying to hit the dimensions of the 23 millimeters yet. So first we'll machine all sides, then we'll try to get to the 23. Alright. Okay. Now that I look at the machine side, I don't see any high spots or low spots, everything is flat, so that means we machined out all the irregularities. So I'm gonna take it off the vise again, deburr, rotate it, so basically repeating the process. Okay, so I have 3 of the sides machined. You can see the surface finish. And now, since these 3 are done, I'm gonna do the 4th one, and this time I'm gonna vise it up like that, so the clamp is going to be here, and I don't need to use the circular part anymore, because this should be and this angle, those should be 90 degrees by now, because like, at least to some extent, because we machined it and this is not off the straight stock. So if the side touching the parallels and both sides of the vise are machined, then this should stay perfectly flat, and we don't need to use the circular tangent thing anymore, and we should be able to get both the parallels tight. So yeah, let's see. Okay, so I've cleaned the parallels and the vise, so I'm gonna put those back. And again, as I mentioned, I will put the machined sides against the fixed jaw, the moving jaw, and the parallels. And let's see how parallel we got it. Alright, so I got 4 of the sides of the cube machined. So that side, all of those are machined. So now the only sides remaining are the ones in this end and that end. But if we try to use the face mill we have now, we will have to clamp it like that. But the small problem with that is the underside is unmachined. So if we want the best accuracy, the underside also has to be machined. Alright, so what I will do is I will use a solid end mill, so this one, to kind of mill out the side like that. Instead of like the other face mill doing the facing operation at the top, I will do it from the side. Alright, so we will take this and we will take the parallels, the fixed jaw and the moving jaw, they will all have contact with the machine surfaces that we did now. So it should sit perfectly in there. And we're going to come at it from the side. But one thing is, I don't personally like the surface finish this end mill leaves behind after doing the side milling. So what I will do instead is I will take off a bit using this mill on both sides. And for the hitting the actual dimensions, I will again switch to this one because it leaves a nicer surface finish behind. So yeah, and one thing for the arbor mill, if you remember, I just chucked it in there, just took it from there and chucked it in there. But the end mill, you might notice that I can't just put it there like directly. So I have to use an end mill holder, and yeah, and we have multiple end mill holders. So I will choose the one that matches the diameter of this. This is a 12 millimeter solid end mill. So I will use a 12 millimeter holder. I will chuck it in there. There we go. And there's a flat part of this mill that needs to align with the screw here. So I will try to do that. Let's see. Okay, so now I tried to move it around in there after lightly tightening the screw, and I can tell that when I move it up, it's hitting the bottom flange, and when I move it down, it's hitting the upper flange. So I should be ready to tighten this down. So I will tighten it using an Allen key or a spanner, whatever. There we go. Nice. And I will install this after removing this. Alright, so now I'm going to remove the indexed shell mill arbor, and for that we actually need to raise it up, not just a quill feed, because even if I fully put the quill up, you can still see it, there's not enough space to move this down. I could move the vise to the side a bit, but what I'm going to do is I will put the vise there, and I will put my glove here for a bit of safety, because the operation we're going to do next requires both hands. And I will unlock the machine height. So that's there. And I will raise the machine a bit. And the thing is, to get this out, we have to use the same tools we used before, so the big wrench and the small wrench. And I will put this here. And you can see that if I try to like unscrew this, there's no hand for me to hold the actual tool. So the best machinist that ever lived had 3 hands, they say. So we can't really do that there. So I will put the wrench there and kind of unlock it. So it's unlocked now, but the tool is still not falling out, but I put the glove there just to be safe. And now it's the second hard part, so I will unlock that too. There we go. Okay, now the draw rod should be adjustable by hand. So we'll put the tools back. The tool has still not fallen out, and I will actually put my hand there now. And I will move the vise to the side. That should be enough. And I will just unscrew the draw rod by hand. And it's coming up. Make sure not to drop this. And I will put that back in its place. And I will chuck our new end mill in. So same process, just put it in there, tighten the rod. I will get it as tight as I can with my hands, and then I'll use the wrench. Alright, there we go. Nice. That is not going anywhere. Nice. Okay, I will clean this place up and let's get to the actual milling. Okay, so now we have the solid endmill in place, and this time we're gonna zero from the x-axis because we're gonna do the cut from this side. So we're not gonna do the z0, we're gonna do the x zeroing. So to do that, I will bring the stock there. I will lower the machine height to right above the top of the material, then I will lock the machine height, and now I will continue the height adjustment with the quill feed. Let's see. Alright, I think I'm gonna take this in 2 passes, so I will lock that there first. And now I will try to toss it off. Again, the paper method. $166.19, it's touching it, so 166.19. We're gonna put it to 166.29 by adding the thickness of the paper. There we go. And again, I'm not looking at the z axis now, I'm looking at the x-axis, so that's in the DRO right here. So 166.29, I will zero that out, and now I know where I need to touch off. Okay, so for the solid endmill, I checked FS Wizard again for the feeds and speeds because it differs from the shell mill orbit that we just did. So I'm gonna put it according to that, and I'm gonna take a very small pass because I'm not trying to hit dimensions yet, and I also don't want the surface finish of the ball and the solid endmill. So yeah, let's take a very light, maybe 0.2 millimeter or 0.1. Okay, let's go with 0.2 millimeter depth of cut. I will put some cutting fluid on and turn the machine on. There we go. And actually, let's take the cut. Alright, so before we take the cut, now we're gonna look at the direction we're traveling. If you look at the endmill, it's rotating this way. So if you look at it from the top, it's rotating clockwise. And there's 2 types of milling. There's climb milling and conventional milling. So conventional milling is me going against the rotation of the tool. So if it's rotating this way, if I go this way, that is conventional milling. So if I move the stock piece there while it's rotating like this, that's conventional. But if I'm moving that from here to here, so if I'm doing this, you can see it's going along the direction of the rotation of the tool. So that is climb milling. And in older manual milling machines like this, it is preferable to use conventional milling because it is not affected by backlash. But if you go with climb milling, which is actually preferable in modern CNCs, it does leave a better surface finish, it has less tool pressure, but in these kind of machines, backlash might be a problem with climb milling. So I'm gonna do a conventional milling cut here. So I'm gonna go from here to here because the tool is rotating this way. And I will take 0.2 depth of cut. But before that, ear protection. Alright, so we are done with machining all 6 sides of the raw stock. So all of those sides are now machined. And now we can finally start thinking about hitting the dimensions. So each side is supposed to be 23 millimeters. And let's see how much we're at right now. And I will use a micrometer. Alright, now that dimension is reading about 23.65. That means I have to remove 0.65 millimeters worth of material. So therefore I will mark 0.65 just so I can see. And I'm not gonna machine this and this side now because both sides are already machined. I will just remove material from the top so I don't have to revise it. So I will just clamp the material like this and I will take off the 0.65 in a few passes. I will do maybe like a 0.4 or 0.5 millimeter depth of cut pass first. Then I will do a finishing pass with a less depth of cut. And I will, again, once I do the first pass, I will measure the stock once again to make sure I don't go over the depth of cut I need to for the second pass. So first, vise this, and then do zero the tool, then take the first pass, measure again using the micrometer without letting this off of the vise, then do the finishing pass with the dimensions we need to do.
How's it going?
Good. I got the first face chamfered. I'm gonna start doing the holes